There's a little bit of a delay. Okay, so it's 9 o'clock, you guys. Why don't we go ahead and get started? Um, just so you know, uh, this meeting is being recorded. So if you have questions, just shoot me a text or something. My name is Brittany Savage. I'm part of the safety team, and we have Dr. Schaeffer on the line. She's going to be doing a presentation and a Q&A session on COVID and the vaccines. And I know a lot of you already submitted questions, but we'll save questions towards the end. Um, and if you have questions, you can either raise your hand or you can text it to me and text it, message me, whatever, and I will ask Dr. Schaefer. And so she's a little bit of an introduction for her. She's been, Dr. Schaefer is the CEO and owner of Apiro. Is that how you pronounce that? Statistical consulting. Her background is in microbiology, epidemiology, public administration, and educational leadership. She previously worked as a state epidemiologist at the state of Iowa Department of Public Health for 9 years. She managed the Medicaid and data acquisition for 6 years and has an epidemiology consultant for the last 18 months. She has also taught epidemiology at Drake University, and Dr. Schaefer supports the Central Iowa Emergency Operations Center, hospitals, businesses, and many school districts through as we navigate through this pandemic. So she has a lot of experience, and she comes at it from a different perspective, I think, than the chief operating officer that we had the last time speak. So she's very knowledgeable. Viruses is her bread and butter, so I'm really excited to hear what she has to say. So, okay, and so with that, I'll ask everybody to make sure that their computers are muted, and then I'll mute mine as well, and then we'll save the questions for the end. So, there's if there's anything else, we'll get started.
Okay, I'll take over the screen here. And just to reiterate, we'll walk through a lot of information this morning. I have a great list of questions from you guys. Thank you for submitting those. They're wonderful questions, and I think we'll hit most of them as we work through the presentation, but any that we don't, we'll go through them at the end. And then if you have other things you want to ask, I'm happy to take it. Most of the time, I've probably heard the question at least once, although there's new things that come up all the time. So don't be shy about that. That's no problem for me. Well, as Brittany said, yes, I'm a longtime epidemiologist. I've worked in public health in some capacity for almost 20 years. Respiratory pathogens are my favorite thing. Flu is probably my favorite disease, but COVID has a lot of translatability to flu. So we're going to talk a little bit in the beginning here about how this came to be. Why did this happen? Is this going to happen again? Why do I need to worry about this? Just all the things that I think help put this in context as opposed to why do I have to do this or why did this happen? But really setting the stage for this is what happened, this is why it happened, and this is why we have to take certain steps moving forward to try to either quiet this down and or prevent things from happening again in the future. So these are all the topics we're going to cover in brief. We're going to talk about the origin. We're going to talk about what's going on right now, about what to expect the next 6 months, the next year, the controversies, myths, what's factual, what isn't, what do we know, what do we still don't know. We're going to talk a little bit about flu and then also about what healthcare and public health are trying to do to fortify our infrastructure for the future. So starting at the beginning, and I know this is probably a lot for general public language, but I think it's important to recognize that this is by far not the first new to people pathogen that we've had. We've actually had 3 different coronaviruses that were new to people since 2002. So I'm sure you all have heard SARS. SARS was super scary. We'd never in public health We never saw coronavirus emerge from civet cats. And just by the way, a lot of crazy stuff happens in China, and we'll talk about that in a minute because there's a lot of commingling of animals and people. And whenever you have that, you're going to have emerging diseases. So, coronavirus is actually the second most common cause of the common cold. So, a lot of the times when you get a cold, it's either rhinovirus or it's coronavirus. But coronaviruses usually don't cause severe disease. So, when this happened 20 years ago, it definitely raised the world alarm. So SARS was contained, it didn't spread really well person to person. And then 10 years later, another version, a new coronavirus came out of camels, of all things, in Saudi Arabia. And then, of course, the third iteration was COVID. But then there's all these other things that have emerged that were new to people too over the last 50 years. Dengue's new to people. I'm sure you remember West Nile virus. That was one of the first things I ever did in public health was pick up dead birds, crows, and blue jays and cardinals from people's yards. Lyme disease is fairly new to people, Ebola and Zika virus. You probably have heard about all those in the news in various points of time. Those are all new to people pathogens over the last 50 years. So, how do these new diseases emerge? And not to slam China because no country's perfect, but there is a cultural phenomenon that happens there and in Vietnam and Taiwan and a lot of other places in Asia where there's a lot of commingling between live and dead animals and people. So, there's animals that are raised on site that are literally the source of food and survival for families, but then there's these massive live animal markets and dead animal markets where you have a bunch of people that interact with different species of animals. And that is a scenario that is ripe for new viruses to jump from one species to another, adapt, evolve, change. And then you also have all this other stuff going on in global society, like migratory birds, and they carry flu. And then you have bats that are moving to different habitats because of, people moving or construction or whatever drives bats out of their habitat. And then they also migrate. Bats are massive reservoirs for a lot of human diseases because they have a lot of mammalian adaptations. So they carry a lot of junk. Ducks and geese, migratory birds carry a lot of junk too. So you have all that commingling, and that's part of why so much comes out of China. Now, China, to their credit, has a pretty remarkable surveillance system. But what they don't do well, and I think we all in the States wish they did better, is share information. So that's one of the things I think in the future that will grow between public health. China finds things very fast, but they also are the root of a lot of infections just because of cultural reasons. This is an example too, though. This is the Middle Eastern respiratory virus I was just talking about, the second new COVID virus that came out. There were a lot of animals involved in this. So, most of the time with viruses, especially ones that don't jump to humans very often, you have a bird species that holds on to it. So for flu, it's ducks and geese, like I just mentioned. Bats hold all sorts of nasty things, everything from HIV to Ebola, and then things like monkeys or pigs, or in this case, camels can be that intermediary where they might not necessarily get sick. Some of them might get sick, and then they pass it to people. So there's this process of adaptation that happens. And what's really hard is it's difficult unless the animal itself is sick or unless you have very extensive surveillance programs in large populations of animals to find those diseases. And so with COVID, unfortunately, that was something that we just didn't find. So, how are pandemics identified? This is a tricky part of the science that I think has been really heavily debated. And what I'll say is, we know a whole lot in science about how viruses change over time. And I find this absolutely fascinating. So, I do a lot of research on influenza with CDC, with other state partners, with a lot of folks. And we can see, and I just think this is amazing, how the different genetic components of that virus have changed over time. We don't always know what every single part of that virus does, but we can see where it has acquired genes. So if you take like the 1918, 1919 Spanish flu, I think we've all heard about the worst flu in the history of mankind. That virus came from birds, but the genetic components of that virus from birds actually came from horses, of all things. So we can look through that genome. We can kind of see where the virus has been, where it's picked up new genes, and how it's changed. So we can see here we've got the original SARS-CoV. Then we got some bat adaptation in here. I told you bats are nasty. They hold all sorts of things. Um, then it shifted to this Middle Eastern strain, adapted to camels, dromedary, even alpacas, and then it emerged and evolved further into COVID. Now, do we know where it came from? No, we don't really know where it came from. Could it have happened from a lab leak? Possible. It has happened before. There was actually a pandemic or an outbreak of flu in, I think, 1964, no, 1977 in Russia that happened from a lab leak, but it was fairly contained. So the suspect thing about that to me is a single leak with a virus that, yes, it spreads well, but until Delta, it didn't spread exceptionally well would be weird because it'd be one person, it would have to affect a bunch of people. That would be hard for the virus to pick off. But again, it's not impossible. We may never know where it came from. I really hope we figure it out someday. It could also be an animal reservoir that we just haven't found yet. So, like the original SARS, we found civet cats were the host for that. West Nile viruses, mosquitoes, and birds. Sometimes it just takes a couple of years to find exactly which animal is the host for the virus. So, this is the illustration, just another one about influenza. And just to give you some assurance, this type of sequencing and sharing of genetic information happens constantly for many, many different viruses that are threats to human health. And different nonprofit, non-governmental organizations catalog them. This information is readily shared. So even though China might not have been the best partner in the beginning of the situation, they did at least provide the genetic sequence of the virus very, very early after it was detected, which helped various countries develop tests and start to work on the vaccine. So, where are we at right now? Uh, this has just been an interesting ride, and it's very, very difficult as an epidemiologist to predict the future with something like influenza or RSV or viruses where we have historical experience to draw from. We can usually tell approximately what's going to happen and what those influencers are. So I'm going to show you a graphic later toward the end of the presentation that shows you how weather, temperature, and humidity impact flu. So you can really predict flu on the basis of weather, no matter where you are in the country, even in Texas. But especially in states like yours, Oregon, Washington, even my state of Iowa, there's a lot of temperature dependency with respiratory viruses. So what's happening now is we had a mutant. We had another coronavirus mutation, which, side note here, another motivating factor for a vaccine is the more people this infects, the more opportunity it has to change. And you can even have situations, and this happens with flu a lot, where you can have two different kinds of the same virus that are infecting the same person and they can share genes. And we don't want those situations to happen. But the more people that get sick and the more we allow the virus to spread over and over again, the more it's going to change and the more it's going to evade our treatment, our therapies, our vaccines if we don't get it under control. So that's a hard one, I think, to get you intrinsically or personally motivated, but it's something that really weighs in the minds of most epidemiologists. So we saw Delta. Delta rose out of mutations from across the world in the UK, really first in June. And so it caused a big surge there. We saw that happen. And then we saw Missouri and Arkansas explode. Then we saw the whole South explode. And what was really interesting is even though, and we'll talk a little bit more about this in a minute, even though vaccinated people can get Delta and can spread Delta, vaccinated people don't typically get sick with Delta. So there's a difference between being infected and having this virus, which it starts in your nose, and it replicates like crazy in your nose. And and if you're vaccinated, once your body starts to see it as the virus travels down your throat, it takes care of it right away. But that initial phase where it's kind of in your face, you've just gotten it, you can spread virus. So you're infected, but you don't know it and you don't probably get disease. So that's one of the benefits of vaccination. Yes, you can get infected. Yes, you can spread it, but it's for a very short period of time and you're not likely to get disease. And most people who are vaccinated are not going to become seriously ill or die, who are at risk. So those are all good things. So we saw that happen with Delta. So we saw the South rise. We saw all of these states where their vaccination rates are kind of hovering around 50%. You guys in Oregon have just started to come down from your curve. Um, that is all starting to level out, but really tightly aligned with the states that had under vaccinated folks. So we've got to boost that up to 70 to 80% to stop these surges from continuing, to further protect the population, reduce hospitalizations, and reduce the burden on our health system. So there's a multitude of reasons for vaccination. We'll get into all of those. And I know there's, there's a lot of personal decision making that goes into it. And even though I've been working in this space for a long, long time, it's still something that I think about in terms of my kids. I have a 17-year-old and a 14-year-old. I have little nephews. I have parents who are older. We have a lot of situations that affect us personally. And so hopefully we'll be able to walk through each of those and talk about the best choices too. So what about hospitalization? So here's our first little baby surge. So when we talk about squish the curve and we all isolate and everything, it worked. Totally worked. First curve was not a big deal. We saw another surge in the summer, probably because, we relaxed a little. We had 4th of July, people interact with each other, and boom, we had another one. And then this was the big one. And I think we all remember November, December. It was a really difficult time, a lot of school closing. I know about lost my mind with my kids being out of school, but we didn't have vaccine yet. We didn't have exceptional therapeutics, more and more being developed every day. And then we saw a couple of blips after that too, little things that had to do with spring break. Here's your post spring break surge. Then we came down to a really low level. And I mean, I know I personally was like, okay, I can take my mask off. I feel okay. And then Delta came. And then we saw what Delta did in the UK. And then we saw what Delta did in the US. So that now we're coming down off of that curve, and we'll talk about what to expect the next couple of months to year in a moment. This is just another perspective. I wanted to put some Oregon specific data in here. So your counties in the east are quite large, so it's difficult to drill into those spaces, but your curve is coming down. You had a pretty substantial one, even more substantial than what was in December, which is actually kind of unusual. A lot of states came close to their peak from last year, but not exceeding that. But still, a pretty significant surge of cases. And if you're averaging over 2,000 a day, that's a lot of disease. So, what about milestones? What about the emergence of vaccines? There's so much in the media right now about the vaccine process, and the process is really confusing. And it looks and feels different than what we've seen with pharmaceuticals and therapeutics and their approval process happening in the past. So the United States actually has one of the slowest medication or therapeutics approval processes in the world. A lot of European countries have a much more succinct process in terms of review. But what we have, and I hope this isn't too much detail, is we have the FDA, Food and Drug Administration, that reviews the safety and efficacy data of the vaccine. So they want to see everything. Clinical trials from the very beginning. How did this affect human cells? How did this affect animals? How did it work in small trials of people? Then how did it work in large trials of people? And then even after a therapeutic receives emergency use authorization or preliminary approval, there still is a 2 to 4 year period after that approval where the FDA is still monitoring safety and efficacy data. So just because a medication is out there doesn't necessarily mean it's not being continuously evaluated. It is, and that's a requirement of EUA until they reach full approval. Even at full approval, there continues to be monitoring. So it's a big, long process. So what we had in terms of the vaccine being put together is that process and that decision for the vaccine composition happened, I think, late January, early February, and it was a decision on the part of two CDC researchers who are very experienced in mRNA technology and knew a heck of a lot about coronaviruses. So that technology had actually been in use in research and actually used for the development of Middle Eastern respiratory syndrome vaccine for 20 years. It just hadn't been brought to market yet because Middle Eastern respiratory syndrome is a very rare disease. It happens mostly in the Middle East. We knew we probably needed a coronavirus vaccine that was an mRNA structure, but it hadn't been brought to full market yet. But we knew this technology was very fruitful. It could be ramped up fast, and it was pretty low risk because you're not growing it in eggs. You're not dependent on cell lines, and we'll talk about beetle cell lines in a minute. Um, and it basically carries in particles of the the genome of the virus. Your cells make more of it. Your body thinks it's infected, and then your body develops all these warriors to fight against what it thinks is infection. And then while it's creating those warriors, it creates a blueprint so it can remember how to make those warriors when it's infected again. And that's really how all vaccines work in one way, shape, or form. It's just the mechanism for getting your body to recognize that it thinks it's infected is different. So mRNA is a different delivery system than, say, what you get with the MMR vaccine or the flu vaccine. They're all a little bit different mechanisms. So we had full approval now of Pfizer. So Pfizer's a great vaccine, Moderna's a great vaccine, and we'll talk a little bit about some of the serious or adverse outcomes that we've seen with some of those, albeit not really at a rate that's unexpected. We see some semblance of side effects with all vaccines, though always at a very, very low rate. And we try to mitigate those in public health as much as possible. So what do we expect now for October, September, October, November, December? Sorry, my months are off out of sequence there. So we're waiting for Moderna to get full approval, and that's 16 and over. We're also waiting for Moderna and Pfizer approval for full approval for 12 to 15. So if we remember right, 16 and older, that was the first group of people to get vaccinated. So now 12 to 15 was the second group. Now we're also waiting for 5 to 11. And so there's sort of the parallel processes of expanding the age groups, but then also obtaining full approval because we've had enough of an observation period now to prove that the vaccines are working as expected. So 5 to 11-year-olds, that safety and efficacy data is public. All safety and efficacy data, clinical trials are public. They're all published in the New England Journal of Medicine. They're not the easiest papers to digest, but they are available. So you can look at the sample size, you can look at the rate of side effects, you can look at side effects in people who think they're getting the vaccine but don't. So they get something called the placebo. I always find that fascinating because people will report things like, oh, I had a headache or a sore throat or I had a fever. Well, you didn't actually get the vaccine, but you still reported some side effects. So there's sort of a mental component to that sometimes too. But it's good to see those data. And I'll give you links to that so you can go there if you're curious and you want to see it for yourself. All of that's available. And so the FDA is going to look at the kids' data from 5 to 11-year-olds now, actually in 2 weeks. And then the second step of the process, we got FDA and then CDC looks at it too. So CDC looks at it from a standpoint of, is the vaccine going to benefit society more than harm society if we don't give it? So they look at all of the risks. So with kids 5 to 11, they'll look at how many kids are getting sick, how many kids are getting seriously sick, how many contacts of kids are getting sick, like teachers, instructors, staff, parents of school-age children. And they actually statistically assess how much less disease will there be if we vaccinate 5 to 11-year-olds. But then they also look at how many 5 to 11-year-olds could be harmed if we vaccinate 20 million people. And what's the rate of that occurring? Which effects will happen? So they look at all of that information. And there are several thousand kids who've already received the Pfizer vaccine as part of a clinical trial. Moderna is not far behind them. So CDC will look at all of those data and they will make recommendations to clinicians. So FDA says, yes, this is a good product, it's good to go. This is how we're authorizing its use. And CDC will say, yes, it looks good. We agree with that recommendation. Here's how you administer it, and here's what you could administer it with. So they'll think about things like, can you give it with flu? Do you need to wait? What if your kid needs an HPV vaccine? Or if they need an MMR or they need other vaccines, can you give those at the same time? So those are all the other considerations that CDC handles that FDA does not. So they usually work really closely together, and very rarely do their decisions disagree. Sometimes they do, and then there has to be a consensus. Either the CDC director will step in or they'll reconvene that scientific body to assess their decision. And it's over 40 different scientists, researchers, clinicians from all over the country that's on that CDC group. So it's super extensive. So what comes after that? Well, we have flu administration too. We'll talk a little bit about the flu vaccine. Absolutely unequivocally should get the flu vaccine for many, many, many reasons. One being there's 4 different vaccine strains in the flu vaccine this year. And even if you've never had flu, you you we have not had exposure to flu like we usually do over the last 2 years, so a year and a half maybe. So the vaccine is going to provide our body with that reminder that, hey, you still need to remember how to fight flu. Remember these viruses? Well, that's what the vaccine reminds you to do. So then over the winter, we will probably see potential changes in dosing. So it might be that we go from a 2-shot vaccine to a 3-shot vaccine. That's possible. We'll see more trials for things like combination vaccines. So, like, we might see combinations for influenza and COVID, where it's one shot, but both viruses um, in that vaccine. Booster dose administration, we'll talk all about boosters in a minute. Full approval of Pfizer and Moderna and those expanded age groups will probably see that too. And Johnson and Johnson. Now that those trials are just slugging along a little bit slower. And I think it was CDC, potentially FDA too, asked the manufacturers to expand their trials of children ages 5 to 11 before they evaluated the safety and efficacy data a few months ago. So that was done. Well, what do we see next year? Getting through the winter, I think, is going to be the most tenuous time, in part because we're all kind of back around each other. Kids are back in school. So we're already seeing some respiratory viruses ramp up to a significant extent. So we know we're going to have flu. We know we're going to have pneumonia. We know we're going to have infections of all of those viruses plus COVID, which could mean for a tricky winter. Will we see another surge of COVID? I don't know. I don't know. We can't say for sure. It would seem likely, but it also, since Delta was so substantial, would seem like it wouldn't be as severe as previous strains. So the caveat with that is if this thing mutates again, and then we have challenges with it matching the vaccine or our therapeutics, then we could be in a really bad situation. But so far, we haven't seen strains that have dominated in the community to show that that will happen, but it still is always a possibility. So 2022, more vaccines hopefully become available. We start to see 2 years worth of clinical trial data for vaccines. We might see variants emerge, but at the same time, there are a bunch of manufacturers working to target parts of the virus that stay the same as it replicates. So, more targeted vaccination that can handle when you have mutations of the existing viruses. So, that potential is phenomenal. If we eventually get to that point, then we could squash this thing forever. And then I think moving forward in future years, hopefully this becomes something that is more seasonal. What we see with most flu pandemics, and we know this is not exactly like flu, it's not showing a lot of seasonality right now. It actually doesn't survive at low humidity like flu does. Flu thrives in times of low humidity and really cold temperatures. But what we could see is some cycles to that. So with flu pandemics, you see big surges, multiple waves, 2 to 3 waves of infection, and then that virus tends to linger for at least a decade or more. So that's what happened in 1918, that's what happened in 1954, 67, 77, and 2009. So you'll notice when you get your flu vaccine, now it still contains the pandemic strain. Reason being, we still see the pandemic strain every single year. So it's still hanging around. So before we get into myths and talk about all the controversy and issues around COVID vaccination and other concerns, what still works? So I'm going to give you hopefully a bunch of resources at the end of the talk that you can go back to and research yourself. Masks still work. Are masks perfect? No. Are they 100%? No. Does it depend on what kind of mask you wear? Yes. Um, There are definitely varying grades depending on, is it two-layered? Is it single layer? Is it an N95? Is it strapped to your face well? Is it gapping? Is it in between your lips? Is it covering your nose? Does it have an aluminum strip to make it fit to your nose? All of those things make a difference. If you're wearing, though, a face covering, mostly of any kind, you're going to reduce the amount of particle that leaves your nose and mouth. So I talked earlier about how the virus replicates like crazy in your nose. Well, it also does the same thing in your throat. So if you're covering those spaces or those parts of your face, you're greatly reducing the amount of virus that can get out of the mask and spread into the air. So that's the premise of how they work. I think somebody is not on mute. Just a quick reminder there. I have a graphic a little bit later that shows the different types of masks, different levels of protection, still a good reduction, but no mask was 100%. Now, I think there was one question about what if we're both wearing N95s and we're talking to each other and one person has COVID and one doesn't? Is there a risk? Yeah, there's always a risk, but that's going to be a pretty small risk, especially if you have adequate spacing, the N95 fits you well, you wear it regularly. The risk is going to be super, super low, and that's good. Somebody who is actually feeling sick with COVID has way more virus than somebody who isn't feeling sick with COVID, especially if they're coughing, sneezing, and have a fever. So those are the people where if you're wearing an N95, yes, there might be a risk, albeit small. So if you're sick, stay home from work. Yes, you can still spread it if you're asymptomatic. But that kind of mask does significantly, substantially reduce transmission. One last thing I'll say about masks, and I know those are controversial. You get really tired of them. I totally get it. I'm trying to frame mask wearing right now as, let's think about it in terms of seasons. Do we need to do this forever? No. Do we need to do this right now? Yeah, right now when we're coming down from Delta and there's still a lot of spread in the community, we do. We really do, especially in situations where you're in close proximity of a lot of people and you don't know where they've been. So that's a good idea. So my kids, for example, beginning of the school year was like, you know what? I live in Iowa. Iowa's not doing a whole lot to protect people from COVID right now. You guys got to wear your masks in school. So they did. Their school district still had 1,000 cases in 6 weeks, 30,000 kids school district, even with masks, loosely used because they weren't required. So it did reduce transmission, but then once it was a requirement across the district, their case rate dropped to a fifth of what it was before that. So yes, they work. Yes, it's a season. Now we're coming down out of Delta. I'd say 2 or 3 more weeks, at least in my state. Your state might take a little bit longer. We can relax a little. Might not have to wear them all the time. So kind of like it gets cold, you get out your winter coat, gloves, hat. You protect yourself for a couple months. Think of the mask in that way. And even social distancing. Okay, Delta's low or COVID's low. We can relax a little. And then we just are aware of, okay, when things start to pick up, then I need to protect myself and my family again. Social distancing, that still works. It works for everything. And I mean, every virus, even the puke viruses, if you distance yourself from people, then that reduces a bacteria or virus's ability to spread to other people. Hand sanitizer works if your hands are not visibly soiled. Washing your hands always works. Hot water friction is a big part of that. That's why they say 20 seconds you're singing the happy birthday song. Um, General health and well-being. I admittedly am not very good at getting good sleep. I try, but I like to stay up late and I like to get up early, and those things don't mix well. But when you don't do those things, you don't eat well, you don't take care of yourself, it reduces your body's ability to fight infection, especially as you get older and especially as you have health conditions that further jeopardize your body's ability to fight infection. So those are all important factors. Thinking about the people you spend time around. I know my family, we kind of had our own little bubble over the last year. We really only spent time with each other. We got out a little bit more this summer, but we're still mostly just doing stuff outside, not traveling, just, kind of keeping it chill until this Delta comes down a little bit, and we'll probably continue to be safe through the winter. But doing stuff outside, that's great. Outside is great. I don't know that there's really a need to do much in terms of restrictions outside. And then ventilation. HEPA filters work well. There's a ton of literature and research now on different filter types that you can use in closed spaces to help purify the air. Another question we got is, how is this different from flu? Well, there's always a lot of confusion about, well, is it allergies? I'm sneezing. This happens every time. It gets to be this time of the year. Is it like a cold? So how are these things different? So I have a symptom comparison here that I think is pretty helpful. So the things that are, I think, differentiators with COVID is shortness of breath, difficulty breathing is a big one. Fatigue, fever happens often. Cough is usually something that happens. Occasionally, you might get a sore throat. That one's pretty rare. You lose your sense of taste and smell. Sometimes people who have long COVID can lose that for up to a year. I mean, it's a really long time. It's really, really bad. With flu, the way that people have described it to me is you feel like you've gotten hit by a truck. And even if you've never gotten flu in your life, it only takes one time for you to get flu and feel like that, and then you'll want to get your flu shot for the rest of your life. So the way I try to frame the flu shot with people too is it provides multiple benefits, but one is you get the shot, then you're not sick for 2 weeks. You get the shot, then you don't have the risk of getting flu 2 times in one season. But the other cool thing about getting the flu shot year after year is your body starts to recognize the pattern. So it sees that every year you get a booster, you get a reminder of your body's immune system of, oh, okay, I need to remember how to fight influenza. That's why you get the vaccine in October. Then, if you get exposed to it, which you will regularly throughout the winter, then your body knows how to fight that. So those micro exposures don't become infection and then disease. So all good reasons to get flu. I've gotten flu literally every year my entire life. Only one time in my family have we had flu that was really serious, and it was pandemic strain. My kids both got it. I had one kid in the ER, and it was before they were eligible for the vaccine, but they recovered very quickly. So that was good. And my kiddo that got sick also is asthmatic, so he was extra susceptible. So colds, much less severe, rarely have a fever. You don't really feel like you got hit by a truck, but you're like, oh, this feels awful. One other thing I'll say about this right now too is there are a lot of other viruses. It's not the next slide, but I have one a little bit later that are making people sick right now. And so that's kind of clouding the scenario. So if you feel a respiratory illness coming on, even if it's a sore throat and a runny nose or cough or fever, if it's respiratory in nature, you still should get tested for COVID just to make sure. But there are a lot of other things it could be. Parainfluenza, adenovirus, rhinovirus. There's a lot of other viruses that weren't really circulating last year. And now that we're all together again, they're like, woohoo, it's party. So they're spreading all over the place, especially in schools. So we're definitely seeing a big increase in some of those surveillance respiratory diseases that help us figure out what's going to happen with the bad ones like flu and RSV. So let's talk about risk factors. So I know a lot of people are thinking, okay, I'm 30 something, or I'm 20 something, or even I'm 40 something. I'm a generally healthy person. Am I seriously at risk for COVID? Why do I have to get vaccinated? Well, a multitude of reasons. Some of the reasons listed here are ones that a lot of people deal with, but some of the biggest ones that I think people discount or being overweight or obese, that puts you at high risk for serious COVID infection. 85% of the US population is overweight or obese. So that puts a lot of people into that category. That, in and of itself, weakens your body's ability to fight the infection. Now, if you have something in addition to that, you have early onset, you have type 2 diabetes, you have type 1 diabetes, you have high blood pressure, you're on medication for blood pressure, you are at risk for heart disease. All of those other conditions, even if they're ones that are just emerging, can reduce your body's ability to fight infection. So most people fall into one of those categories, especially by the time you're 40, if not more than one. That in your 20s and 30s, yes, it definitely is about protecting you as a person, but it's also about protecting all of the people that you come in contact with. Because people in that category and even little kids can get the infection, not know they're infected, spread it to people who are seriously ill and susceptible, and it keeps perpetuating in society if we don't do that, if we don't get vaccinated. Some things about Delta and why Delta is crazy. Delta is definitely not the most infectious pathogen we have on the planet, but it's pretty transmissible. And the single reason for that is it makes a whole ton of virus. So the original strain on average would spread to 2 people. Really, honestly, like 1.5 people to 2 people when we got into those bigger waves last winter. So then the strain mutated, and now Delta, if you are a person who's infected, not vaccinated, and become sick, you on average will spread Delta to 5 to 8 additional people throughout the course of your illness. In part because you can spread disease for up to 10 days and even before you know you're sick. And you're producing a ton of virus. So if you're not using a mask, you're not vaccinated, the chances are really good you're going to spread it to somebody else, especially somebody in your household. And this is a lot different than what we saw a year ago, where you might have 9 people in a household and only 1 or 2 would get sick. So there was enough distancing and isolation and immunity for people to be protected, whereas Delta has pretty much obliterated that. So a lot of the um, studies and situations that I encounter now as husband and wife, people cohabitating, close coworkers, kids in school, playmates, you just don't see one individual case anymore. It's always cluster. So that's what Delta has done. But please know, I mean, it could still become even more transmissible. So we have viruses like mumps and measles being the most infectious respiratory pathogen on the planet, where if you have measles, you go into a waiting room, you can leave, and 2 hours later, somebody can come in that waiting room and get measles. That's how infectious that disease is. So we don't want to get to measles level spread. That would be very bad. And the more protections we do now, the more we squash this, the less chance we have for that to happen. All right, let's talk about myths and challenges. I already had COVID. So I've come across this a whole lot because that first wave, even the early wave, we had a lot of people who got sick who did develop good antibodies, but there's this huge spectrum. So this is not a straightforward answer. But but the moral of the story is even if you've had COVID, you have varying levels of protection that happen as a result of that infection. So if you were infected and you didn't know it, you have really weak antibodies. If you were infected and you got a little sick, you have better antibodies. If you were super, super seriously sick with COVID, hospitalized, almost died, you have really good antibodies. But natural immunity from infection doesn't last that long, especially if it's not challenged. So if you had COVID, what the vaccine will do for you is remind your body on how to fight COVID in the future so you can't get reinfected. So if you had COVID in the past, the vaccine acts like a booster. It's a reminder. Remember that blueprint body. You've got to remember how to make these antibodies. The second dose gives you like super immunity. So that's really, really good. The other thing we're seeing too with Delta is people who had infection before are becoming sick again more readily than anybody who had vaccination. Now, their studies are kind of mixed on this topic as far as which is best. So if you had COVID 3 months ago, then you probably still have decent immunity. But we're heading into winter. We could have mutant strains. Getting that booster and getting that body's reminder is going to be important. You can still get Johnson and Johnson, or you can get one of the 2-dose vaccines. They will all help challenge your body in the same way. It was developed too fast. So we talked about this technology. It's been around for about 20 years. So far, it has been, and I mean, I've witnessed the release of the varicella vaccine in 1996. That's chickenpox. When that was released, a lot of people were like, my kids, I had chicken pox. I'm just going to let my kids get chicken pox. Well, the problem with that is that herpes virus lives in your neurologic system forever. So once you get chicken pox, you always have that virus. That virus can emerge then when you're 50, 60, even 30 in the form of shingles. And then that shingles can give people who've never had chicken pox chicken pox. So it's definitely a disease to vaccinate against. Well, we gave that shot in 96. A couple years later, we realized, okay, there needs to be a second shot. And so now you almost never hear of chickenpox. So, not a disease that killed a lot of people, but a disease that really challenged people's immune systems and could make people really sick when they're older. And neurologic viruses are very, very bad. So, this one, not necessarily developed fast, but it's also not unusual to see that dosing change over time. So to see that we need a booster is not really an unusual thing. We'll talk about who needs a booster, why, and what is the science saying in a couple of slides. So that's changing somewhat, but the development process again, we'd had this technology a long time. It had been used in vaccines. They just hadn't been brought to market.
Uh-oh, no, did we lose her? Meg?
Brittany,
Yes, can you hear me now?
can you hear me?
Yes, you froze for a second.
Oh, sorry. Power outage earlier, but
Oh, or yeah, you're still pretty. There you are.
oh, it's okay. Try to bring it closer there.
There we go. Yeah,
Still
it's a little
okay?
bit better. Mm-hmm.
A little bit better. Try to get the headset on too. Okay, just interrupt me if that gets fuzzy again.
Yeah, it's
Okay.
still a little fuzzy, but and you're still frozen in the picture, but
Oh, let me shut the video off. Maybe that will help a little bit.
okay.
Is
We
that
can at
better?
least hear. Yep, we can hear you now.
Okay, good. All right. Sorry about that. Okay, so let's talk quickly about ivermectin. Um, Not a good idea. Not a great therapeutic. So we've had a couple of different things emerge, like hydroxychloroquine and some other drugs that people have purported for use throughout the pandemic. One thing I'll just say right off the bat is if there is a drug that works and that works well and that helps people more than it harms people, the FDA is not incentivized to not use that therapeutic. Like if there's a drug that works, but it's not harmful to people and it works in multiple settings and it's proven, doctors want to use it. But ivermectin is not one of those. And unfortunately, hydroxychloroquine and a couple of other therapeutics were not either, in part because they're used for different purposes. Ivermectin in particular, deworming, antiparasitic, but there isn't enough data to show that it works across the board. So it needs to work in multiple clinical trials, and it also needs to not have harmful side effects. So neither one of those things came to fruition for ivermectin, not universally good for people and has side effects. Same thing with hydroxychloroquine. Worked in some studies, didn't work in other studies, and also caused some serious health outcomes in people who were very ill with COVID. So there are, though, some other therapeutics that worked very well. Monoclonal antibodies work very well, and that's what you get on if you're diagnosed, you're near a hospital. Yes, it's an infusion, it's a little bit of a pain, but it works really well. And now there are pills and hopefully soon to be medications that can treat you that don't involve that type of a process. So, more to come. There we go. Vaccine changes your DNA. Nope, not possible. So the messenger RNA, that is the vaccine strain, it goes into the cell and it uses the cell's machinery to make copies of itself, but it doesn't get into where your DNA is, which is in the center of the cell or the nucleus. And basically, it's just stimulating the cell, creates these proteins, and then it breaks down, and your antibody warriors will kill that cell. So it's not really part of the process. It's not like the virus can't inject its genetics while the cell is multiplying and become a virus. It is just genetically impossible. So, rest assured, vaccine does not change your DNA. Technology is new. So, you talked about how it's been researched forever. So, it actually was researched in two places. Moderna had been researching it for a long time, and I think they're based in Massachusetts and also in Germany. So, different research teams were researching it. Pfizer bought the German technology or the German research lab, and that's what they acquired the technology. Moderna had had it all along. Kids are sicker with Delta than previous strains. Actually, no. This is something that everybody was super worried about because Delta's surging. Oh my God, we're putting kids in school. We don't have universal masking. Not all kids can get vaccinated. What's going to happen? Kids did get sick. They did, but proportionately to what they did before. So in some states, we did see big surges in kids getting sick. even in my state, we might have 650 people in the hospital, which is a lot, but only 12 of those will be kids. Still, 12 is more than we want to be dealing with the first month of school. But Delta is not disproportionately affecting kids. Now, a side note on that, that is sort of unique about coronaviruses in that they haven't caused as severe illness of kids, I'd say, under the age of 12, whereas flu does. Flu can kill babies, flu can kill little kids, flu can really impact children depending on the strain. So, one of the things to keep in mind is that all the things that protect against COVID, with the exception of the vaccine, protect against flu. So, mask, distancing, being cautious around who you're with, all of those things can protect kids too from flu. The vaccine is causing a spike in blood clots and deaths. So, this information is important. And I think when you're trying to make that decision, even if it's a vaccine mandate, you want to have information. And I don't know that the information is necessarily being suppressed. It's just difficult to interpret, and it's difficult to find the right resources. Social media is absolutely not the place to go for this information. But I put links in the presentation, and I encourage you to go there and read about it because there is a ton of information and data captured on vaccination for all people in the United States. So, ACIP is the Advisory Council for Immunization Practices. So that's that 40-person scientific group that reviews all that safety and efficacy data, outweighs the benefits and the risks of vaccines. All of their meeting minutes are public. You can listen to their meetings if you want. But the other two places that I think are good are VAERS and SAFE, VSafe. So VSafe is self-reporting. So if you get vaccinated, you can log into VSafe and you log your reactions to the vaccine if you have any over time. The vaccine adverse events reporting system is VAERS. That's actually been around for decades. That is a system where if a physician sees that somebody had an ill effect from the vaccine, oh, I think
Hey,
somebody's not
hey
unmuted.
Meg. Yep. Hey
Yeah.
Meg. I think the slide, the presentation is frozen because it's still on myths and challenges on the second one.
Okay. Not sure what to do about that.
It could just be.
Shoot.